Now we are going to briefly talk about nitriles. Nitriles has a carbon-nitrogen triple bond. Nitriles is a very special carboxylic acid derivative. It doesn't have the carbonyl functional group. It doesn't have CO double bond. However, nitrile carbon has the same oxidation level as the carbon in a carboxylic acid. In carboxylic acid, we have a double bond O attached to the C and a single bond O attached to the C. And we can see the carbon is bonded to a more electronegative element 3 times. Same here in nitrile. We have a triple bond to nitrogen. Again, the carbon is bonded 3 times to a more electronegative element. Regarding the preparation of nitriles, we have seen 2 reactions. The first one is the nucleophilic substitution of the cyanide group. When the cyanide reacts with an alkyl halide, it provides a nitrile. In this case, the R group here is preferred to be a primary group, and the carbon that is directly attached to the X should be sp3 hybridized, because this mechanism is SN2. The second reaction to prepare nitrile is the nucleophilic addition of cyanide to a carbonyl carbon. This is also called the cyanohydrin formation. So cyanide attacks on the carbonyl carbon, breaking the CO double bond. In the cyanohydrin product, the cyano group, Cn, will be attached to the same carbon as the OH. Okay, so these 2 methods are the ones we have learned to introduce a cyano group into our molecules. The reactions of nitrile. First, nitriles can be hydrolyzed to carboxylic acids via amides. That means when we hydrolyze nitrile, it will first give amide as an intermediate. Then the amide will be hydrolyzed further to carboxylic acids. And this is also the reason why we classify cyanide compound as carboxylic acid derivatives, because nitriles can be hydrolyzed to carboxylic acid. The second reaction for nitriles is the reduction of nitrile to primary amines. Nitriles can be reduced by the strong reducing agent lithium aluminum hydride to primary amines. This is similar to the reduction of amides. The next reaction for nitriles is the addition of Grignard reagent to the nitrile carbon. Eventually, it will produce a ketone. So the nitrile carbon is also electrophilic, and the Grignard reagent will attack on the nitrile carbon, breaking one of the carbon-nitrogen bond. And after we add water, after the nitrogen is protonated, we actually form a carbon-nitrogen double bond compound, which is called imine. Previously, when we talk about imine, we say imines are formed by a reaction between a carbonyl of an aldehyde or ketones and ammonia or amines, primary amines. But now we know imines can also be made from reaction between a nitrile and the Grignard reagent. Anyway, imines can be hydrolyzed to ketones or aldehydes. So under acidic condition, the CN double bond can be hydrolyzed to CO double bond. That's the reverse reaction of the imine formation when ammonium or amines, primary amines, reacting with a carbonyl compound. Okay, so the hydrolysis of imine will give ketone as the final product. So the overall reaction here, the nitrile can react with Grignard reagent, and eventually it provides ketone as the final product. And these are all the reactions that we cover in this chapter regarding carboxylic acid derivatives.